Now we go for the next algorithm called naive-Bayes algorithm. Naive-Bayes algorithm stands as a foundational pillar in the machine learning. It offers a simple yet remarkably powerful approach to the data classification process. It leverages the Bayes theorem to make the predictions, proving widely effective in various applications such as text analysis and spam filtering. What is naive Bayes? So it depends on four process. First is what is probabilistic foundation. A classifier rooted in Bayes theorem, it calculates the probability of the data point belonging to certain classes. So it starts finding out the probability of the data point which belongs to the specific classification. Feature independence is it operates on the naive assumption that all the features are conditionally independent for the given class, making the calculation as simple. Next is class label prediction. Class label prediction is to predict the class labels for new and unseen data points based on the learned probabilities. It also, what it means is, it goes for prediction for the labels for the new data and also which is not seen in the data points. All those things it goes for finding out the probabilities of those kind of inputs. Next is going to be very efficient performance. It is very simple process. It is known for being fast and efficient and surprisingly effective across many data sets. So what is Bayes theorem? Bayes theorem, we know that the formula for Bayes theorem is P of A by B is equal to P of B by A into P of B divided by P of A. Sorry, it is a P of A by B is equal to P of B by A into P of divided by P of B. This is what they say is that according to this, what we are going to say that here you are going to have two things. One is class and its features. Features are nothing but the specific points we are going to describe about the particular class. So first one is probability of class to the given features. So this probability is called as posteriori probability. It is the probability of the class given with the observed features. Whatever we are observing it, from with the features, that observed features, with that I'm going to calculate the probability of the class. That is called posteriori probability. Features to the class is nothing but maximum likelihood. It is the probability of observing the features with a given class. So here in the previous case we have defined the class with the observed features. Here we are going to find out the probability of the features with this particular class. Next is going to be a P of class is a priori probability. Prior probability represents the initial probability of the class before any evidence. Whereas P of feature is referred to as evidence, it is the probability of observing the features across all the classes. This is how we define the what is posteriori probability, what is maximum likelihood probability, prior probability, and the evidence probability. Based on this probability classification, I'm going to make use of in my Bayes theorem, and I'm going to find out what the ultimate result is. This is about the what Bayes theorem, what it requires. So what are the name assumptions are made? The name what we are going to make on the core concept simplifies the real world complexity, enables the efficient computation, often violated yet effective only. What is a core concept? What we call it as a conditional independence. This comes from this central assumption that all the features are conditionally independent of each other given in the given particular class, or we call it as a label of the class. For example, if you say that it's a spam detection, the presence of free is assumed to be independent of discount when the classifying email is a spam or not. Often violated is nothing but, while this assumption is rarely preferable and perfectly true in the real world scenarios, that is it has some dependencies. Naive Bayes frequently yields an surprisingly good performance to the robustness and efficiency. Real world complexity is nothing but Independence assumption significantly simplifies the underlying probability calculation, making the algorithm more efficient. Enables efficient computation means it goes for simplifying the relationship between the features of the algorithm, which can process within large number of data sets. These are the some of the assumptions we make on the what classes and the features. So, for example, if you go for an email spam classification, we are going to apply this neighbors can classify the email is a spam or not spam. So we have a data sets of emails and noting that the presence or absence of specific words, that is called features, and the corresponding classes. So what they say is that the email ID, we have 5 mail ID, and the word what we features we defined is one is free, another one is discount, and third one is the what class it is, whether it is spam or not, we are going to detect it. If it is free and no discount means I'm going to say that class is spam. If it is free and the discount is yes means the free is the one we found no, and the discount is yes means it is also spam. Yes and yes means it is spam. Like that, if we are going to create a table based on the features, I'm going to classify whether it is a spam mail or not spam mail. Similarly, we can also take the fruits and you can say that what type, what the classes are: apple, orange, or whatever may be the different fruits we are going to do. For that, I'm going to give a feature. If these are the features, then you classify this is a apple. If these are the features, you say that this is an orange. If these pieces are there, I can classify it as guava or grapes or whatever may be it. So this is how we segregate all those features and the classes, and we are going to predict whether it is this belongs to the particular class or this belongs to this class, like that, and we are going to. So this training data sets provides the basis for calculating the probabilities needed for new buyers to make as an informed decision on whether the new coming emails is a legitimate or spam. This mail is not spam or spam. Based on this, what data say with classifications on the feature, we are going to predict this is the mean spam mail or not spam mail. We have created the table, and next we are going to calculate the probabilities for free discount. So what is the step one is calculating the priori probabilities. Step two is calculating the likelihood priority. Third one is applying the neighbor sample. And fourth one, we are going to compare and conclude that whether what the prediction we made is right or wrong. Step one is calculating the prior probabilities. First, we are going to find out the probability for spam is 3. How many spam things are there? Based on the table, we found that there are out of 5 mails. And not spam is 6. So the probability for spam is going to be 0.6. For not spam, it is going to be 0.4. So next thing is we are going to calculate the likelihood. Likelihood is nothing but probability of free on spam. The word called free is available on the spam, then what is the probability? We found that there are words are there free for spam mail. So it is 2 by 3. The probability is going to be 0.76. For discount on spam is going to be 2 by 3. It is also 0.6. Free on not spam is going to be 1 by 2. It is going to be 0.5. Similarly, for probability of discount on not spam is going to be 0 by 2 is going to be 0. So we calculated the likelihood and priori probabilities. Then we are going to apply it on the naive Bayes formula. So after applying it, we have calculated what is all these classifications, and we found out what are the probabilities values. So after calculation, I'm going to compare and conclude what's the result I'm getting it. After comparing the posteriori probability, I got 0.269 versus 0. And we classify that mail as an spam. So which is the majority, which is the highest probability I'm getting it? Based on the highest probability, I'm going to say that the mail is a spam mail or not spam mail. So these are this how my neighbor's main algorithm works on the base formula. So next, what are the key applications I can go for it? Spam filtering, sentiment analysis, text classification, medical diagnosis, recommendation systems. So these are the what we call for sentiment analysis. Based on the text message, I can feel that the person is sad or in a good mood. Spam means whether it is a right, the mail is a proper male or not proper male, medical diagnosis, whether the disease is present or not, like that I can go for it. So powering the personalized content suggestion, it moves the like move recommendation on the platform such as Netflix, like that the recommendation based on the recommendation I can suggest which is good one. So simplicity and efficient of Neighbors make it a versatile tool across a wide range of real-world applications. Especially, it works on large data sets, and all these things are based on the categorical classifications or categorical or classic. What are the classification we make it on the data? Strengths and limitations are: the strength is fast and computational efficiency for both training and prediction phases. It performs well with a relatively small training data sets, effectively handles a high dimensional data, making it ideal for text processing. Simple to implement and easy to understand the underlying principles. Limitations are: strong independence assumption is rarely perfect, true in a real world data, potentially effective affecting the accuracy. Zero frequency problem can occur if the features isn't present in the training data, requiring a smoothing techniques. Less effective for continuous numerical features. If the features continuously goes for varying, in that case we are going to have a problem called what finding out the miscalculations. So in that case, it is found that this neighbor-based algorithm is somewhat not suitable to that scenario. Conclusion is that it is robust and reliable baseline classifier, particularly powerful for the text and categorical data. Its simplicity, speed, and decent performance make it foundational tool in any machine learning toolkit. This is about Bayes algorithm, how efficiently it works with the Bayes algorithm. Thank you.